We've been around for over 70. We're up at 75 years, and we just celebrated our recent birthday. The reason why is because we're at the crossroads of a jet stream in the Ohio Valley. We're usually the busiest or in the top 2 or 3 out of 13 river forecast centers that cover the entire United States that do river forecasting. So it is busy here most of the time. 9, 10, 11 months out of the year, we have flooding somewhere in the Ohio Valley on a monthly basis that we're dealing with. So we are a very busy office, but we focus, unlike weather forecast offices that deal with lots of different weather elements, from heat waves to tornadoes to everything else. We just focus on moving water from the Ohio Valley down into the lower Mississippi Valley. Well, I think, for 1997, the lead time, we were aware that there was going to be an event on the Wednesday, Thursday, and Friday right before the event that started on the weekend of March 1st and 2nd. But we weren't using any of the technology just wasn't advanced to the point where some of the newer like weather models were hinting at things, but they really didn't capture it until when the event was already started. And where now today, for example, we're much further, we usually have a pretty good idea about a bigger problem sooner than back then. So the differences between now and then are pretty stark. In 1997, we only did a 3-day river forecast. Today, we do 5 to 10-day forecasts. In 1997, we only used mostly 24-hour rain gauge reports once a day, and then some 6-hour rain gauges. Today, we have hundreds to thousands of real-time, hourly, or even sub-hourly rain gauges that we use. We also use radar estimates to estimate the rainfall. So we're much more advanced at the observation of rainfall. We're much better at the forecasting of rainfall. Back then, we only used 24 hours of future rainfall. Today, 48 to 72 hours into the future. We also have probabilistic forecasting that goes out with 10 days of rainfall. So we can have planning tools now to see potential outcomes coming. So lots of improvements in the last 25 years. But still, extreme events really push our abilities to the limits of science. And therefore, when we're talking about very significant events, we need to respect Mother Nature, because a lot of times they can be even more extreme than we even think, because we're pushing the limits beyond almost our capabilities. And so when we're out there on the extreme of an event being very concerned, that probably means it's the real deal. Yeah, so big floods in the Ohio all originate from the tributaries. So like for the state of Kentucky, the Licking Basin, the Kentucky River Basin, the Green River Basin, they all push water into the Ohio. And in this event, they were all contributing. Sometimes you only get one of the smaller tributaries to contribute. In this one, all of them were contributing. And usually all big floods in the Ohio River, they need contribution out of the West Virginia and Kentucky rivers. And that's exactly what we got in this event. We just had a big flood last year in Kentucky on the Kentucky River in 2021. And so these events happen all the time, but they don't happen where all of the rivers contribute that often. And that's where you get the big floods in the Ohio. But those tributaries, where it's important to know is they're really flashy. Even in the 97 event, we referred to the 97 event on the Ohio River as a flash flood event. The river rose over 20 feet in 24 hours in locations. That's really fast for a big river. That happens a lot of times on the tributaries like the Kentucky River or the Licking River or the Green River, but not on the big Ohio. So this was a very intense thunderstorm-based flood. The veteran forecasters from the 1997 flood here at the Ohio River Forecast Center, they were really good about teaching things. And one of the things they always said is, if you're going to forecast record events, you need to ask yourself 5 times, do you really think that's going to happen? And the one forecaster in this event, he forecasted a record event for the 97 flood at Falmouth, Kentucky. And he said the deviation from the previous record to how high he was forecasting, he said he only did that one other time in his career. So he was very concerned. He had come to me even during that event and said, hey, I want your opinion. He didn't tell me exactly what he was doing at the time. And then I thought to myself, after I gave him the answer, he wanted to know how confident we were in the rainfall in the Kentucky and Licking basins. And I said we were using some very new preliminary software at the time that I was playing with, and I said, it looks pretty good that we've had 6 to 7 inches just in the last 6 hours. And he says, oh, okay, and he walked away, and then I started thinking, I better ask him what he's going to do with that information. And when I asked him, he said, oh, I'm going to put out a record flood that I've only done one other time like this in my career. And I'm like, okay, let's talk a little bit more to make sure before we do that. And it turned out, the one last thing, he knew it was amazing. The amount that you get from experience, more than just computer models and college degrees. The experience matters, but he said to me that he just said, I know I'm not going to be too high. And he was about 2 feet too low. That event, some of the big findings were that automated gauges, river gauges and rainfall gauges are really, really, really important. And it was just like, it's a compounding thing with those surface assessments of, learning from them, but it was reinforced in that event of you need automated real-time gauging upstream to help make better forecasts. The other thing is that was really initially spearheaded right back from that event was just how valuable some of the new forecasting tools that we were introducing at that time were to improve the placement of rainfall. And so that event really helped spearhead some of the tools that the National Weather Service, all of the forecast offices now have at their disposal, and it was really started back in that event. But
very cool.
Most of the really big events, like 1997, most of the rainfall falls in the region within a 48-hour period in the research that we looked at. So these floods can happen very quick. It's not like 5 and 10 days worth of rain. 48 hours of rain, the majority of the heaviest rain, 48 hours or less most of the time. That's why we have to be really respectful of Mother Nature.